In this video, we're going to talk about linear functions, what they are, and how to find the slope of a linear function and their equations. So in terms of topics, we're going to be looking at the slope formula, rates of change, which is an application of the slope. We'll see increasing and decreasing functions, the slope-intercept form, the point-slope form, and the linear equation form from 2 points. Okay, so first of all, what is a linear equation? Well, a linear equation or a linear function is any function in the form f of x is equal to ax plus b. And of course, these can be interchanged. We could write that as b plus ax. But the key is that there's an x term and a constant. The a and the b could both be zeros. But it's not squared, it's not cubed. Your x isn't inside a square root. It's just to the first power. In number 1, we have several examples of these. So you can see that in part A, 2x plus 1, a is equal to 2, and b is equal to 1. Because linear equations are so nice to work with, we think of this form as mx plus b. So we can replace this a with the more specific variable m that represents slope. B, again, this form is so nice, b always represents our y-intercept, or the point where the line crosses the y-axis. This makes it really, really easy to graph. So I know that my slope is rise over run, or the change in the y direction over the change in the x direction. We'll see a formula for it here in a minute, but for now, we just want to work with the actual number. In part A, my slope is 2, but I want to think of that as a change in both the y and x direction. That little triangle is delta for change. So I'm going to think of that as a 2 over 1. So this means that I'm going to go positive 2 in the y direction and positive 1 in the x direction to find another point. I'm going to start with b equals 1. That's my y-intercept. So right here at 1, I need to move up 2 in the y direction and then over 1 in the x direction to find an additional point. And I can continue to do this up to over 1 to find even more points. And then my line is going to look something, hopefully a little straighter than mine, but it'll something like this. Okay, let's go on to, I'm going to move to B next. So in B, I have m, or a, is equal to negative 1/2. That's my slope. B is equal to 4. That's my y-intercept. With that slope, I can put the negative either in the numerator or I can put that negative in the denominator. Both of these give me a way to move from one point to the next. So for this one, I've got to go down 1 in the y direction and then positive 2 in the x direction. I know I'm going to go ahead and start at 4 on the y-axis. That's what my b represents. So 1, 2, 3, 4 is going to be this one. I want to go down 1 and then over positive 2. That gives me another point. Again, I can do that. So down 1 over 2 gives me another point. I can also use the other form. This is going to move me up 1 and to the left by 2. So if I go ahead and start at 4 again, I can move up 1 to the left by 2. And that's going to continue to find me more and more, whoops, not that one, more and more points on this graph. Let me get rid of that guy. Okay, so how about up 1 over 2? So it's going to be that one right there. So that gives me this line right here. I really only need 2 points. I'm doing several, which is way overkill. Okay, in C, I don't have an m. So in this case, actually, m is equal to 0. That's going to be no slope. That means I'm not on a hill and I'm not on a gradual decline either. So a slope of 0 means I'm not walking up or walking down. So this is going to give me a horizontal line. I can rethink that f of x, that represents my y value. So no matter where I am, y is equal to 3, including crossing that axis. So I can just go ahead and graph a whole bunch of points here where y is equal to 3. It's going to give me that horizontal line. I can also think of this as cutting through the y-axis at 3. That's my horizontal line. Finally, part D, I have an m but no b. So in this case, m is equal to negative 2. I'm going to think of that as a fraction. B, since it's not there, must be equal to 0. So that means that I'm crossing the y-axis there at 0. Negative 2 over 1, I'm going to go down 2 and then to the right by 1. So down 2 to the right by 1. Down 2 to the right by 1. And that gives me this line. Okay, so this form of the function is really, really nice for graphing. Next, we want to find slope or the rate of change. Those two are interchangeable. To find the slope of this line, I can go ahead and use the same counting that I used before. So to get from one point, I'm going to start here to the second point. We'll call that point 1 and point 2. I need to go down and then to the right. So I need to move down 1, 2, 3, 4. So that's going to be negative 4. And then to the right, 1, 2, 3, 4, 5. So that's going to be plus 5. So m is the change, that's that delta or triangle in the y direction over the change in the x direction. Change in the y direction was negative 4. Change in the x direction is 5. You could also call this a negative out in front of that fraction. So we're going to go ahead and call this negative 4/5. Notice how this line, if I were to walk it, I am going down the line. I always read these going left to right. Okay, in part B, we're finally going to need this formula. So in part B, I want to find the slope of the line through two given points. My slope is still the change in the y direction, that rise, over the change in the x direction, which is that run. But to find the change in the y direction, I need to subtract my y coordinates, and I need to do the same for the x coordinates. I need to keep these straight. So these formulas are subscripted. So it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm just going to label these as a point number 1 and a point number 2. So as I put this formula together, I need to take the second y and subtract the first y. It's going to be 7 minus 3. I'll do the same with my x's. I'm going to take the second x, 4. Notice how those are paired up and down in a point, and subtract my first. Oops, that should be a 2. So I end up with, if I just do the math here, 4 over 2, which is 2. It's going to give me a positive slope. So that slope is going up if I were to walk this one. Give myself some hair. Okay. Next, I want to find the slope given two function values. Well, I want to use the formula that I have up above here. So I really need some x and y coordinates. In function notation, what goes inside the function represents the x. What comes out of the function represents my y. So I can rewrite both of these as points. So the first one becomes negative 1, comma, y is 8. And the second one, 2 is my x, paired with 14 for y. I'm going to call this point number 1 and the second one point number 2. So I can go ahead and find m, change in y over change in x. We'll do the y's first. 14 minus 8. And in the denominator, let's go ahead and do the x's, 2 minus negative 1. 14 minus 8 is 6. 2 minus negative 1, that becomes a plus, so I get a 3 in the denominator, and the slopes are not all 2, I promise, but we end up with a 2 there. Okay, so finally in D here, we want to find the rate of change, but the rate of change is a slope. Okay, so I want to find a slope. The minimum wage in Washington in 2000 was $6.50. So I can go ahead and write this as a point. 2000 is matched with a minimum wage of $6.50. In 2020, we have a minimum wage of $13.50. We want to find the rate of change between 2000 and 2020. So for this one, though, I want to find the change in the minimum wage divided by the change in year. That says MW. Change in minimum wage. Let's go ahead and take the second minimum wage, $13.50 minus $6.50. And we're going to divide that by the second year, 2020, minus 2,000. I'm going to do this in my calculator. In my calculator, I really need to put parentheses around my numerator if I'm going to do this all in one step, and in my denominator. So let me bring the calculator back up. So I'm going to take parentheses and then 1350 minus 650, parenthesis right above that 9 there, divided by parenthesis for the denominator, 2020 minus 2000. Does that look good? Yes. So it seems like a pretty big jump, right? From $6.50 to $13.50, but it turns out to be 35 cents. And if we put this in terms of dollars and cents, let me grab my purple. This is 35 cents. The denominator was years. So this is per 1 year. So 35 cents per year, which really is not a significant increase when you look at that per year. So when it asks for a rate of change, it's the same thing as the slope, maybe just given a specific context. Next, we want to look at finding some equations of lines. There are 2 different forms that we can use, and they're helpful at different times, but they're completely equivalent. The first is the slope-intercept form of the line. That's the one that we've been using. Y is equal to mx plus b, which we can also think of in function notation. F of x is equal to mx plus b, or ax plus b, either one. To get the point-slope form, I'm actually going to just bring this up in terms of the slope formula first. There's my slope formula. When I do the point slope form, I do want an unknown x and y. I do want variables x and y. So I'm just going to subscript the y1 and the x1. Then I'm going to cross multiply. And this gives me the point slope form. So when I cross multiply the difference in y's times 1, I get y minus y1 is equal to, and then I'm going to do m times the difference in the x's, m x minus x1. So this gives me the point slope form, m x minus x1. I want you to know both because they're just more helpful at different times depending on the given information. Okay, here's the first one. Find the equation of the line in the graph below. Well, I notice that I have a y-intercept, so I can get to y equals mx plus b if I can just figure out what the slope is. And it's identified 2 nice points for us. I've got a y-intercept of 1, 2, 3. So b is equal to 3. Let's go ahead and find that slope. Notice that we're walking down the line here. So this is going to be negative. And I need to travel negative 1, 2, 3, 4, and then over 1, 2, 3, 4, 5. So negative 4, this is the same one that we looked at before, plus 5. So m is the change in y, rise over run. That's going to be negative 4 over 5. I don't need any other information. I just need to fill in the m and the b. So my function looks like this. Y equals m, which is our negative 4/5, x plus b, and it crosses that y-axis at 3. So b is that y-intercept. The next one, we're given a slope and a point. So the easiest form to use for that is, you probably guessed it, the point slope form. So I'm going to go ahead and use the point slope form, and I'm going to plug in my information. So first of all, my point slope form is y minus y1 equals m x minus x1. This point here is x1 comma y1. With those subscripts, that's going to be some known values. I also have m. M is my 1/2. So filling in what I know, I've got y minus the y given, which is a negative 1, that's going to change into a plus, is equal to m, so negative 1/2, x minus x1, which is 4. Start to clean this up. Y plus 1 is equal to, I'm going to distribute that 1/2, negative 1/2 x. Negative 1/2 times negative 4, that's going to be plus. I'm going to write 1/2 times 4, and I'll just continue to clean this up. I can cancel the 2. Half of 4 is 2, so that actually becomes 2. Subtract 1 from both sides, and we get y is equal to negative 1/2 x. 2 minus 1 is a plus 1. So that function, y equals negative 1/2 x plus 1. In each of these, you can replace that y with an f of x. So just know that those are interchangeable. You can express that either with a y or with an f of x. Okay, the next one. Through negative 2, 3, and 1, 0. I don't have, so if I was using slope-intercept, I would need an mx plus b. I would need an m and a b. I do not have my slope, so I do need to figure that one out. I need it for either of these two forms, the point slope or the slope-intercept. And I also don't have b, do I? Because this is 1, 0. It's an x-intercept. So I really need to do the point slope formula here. So we're going to use the point slope formula. Let me erase this. Do a little bit of relabeling here. So I'm going to use y minus y1 equals m x minus x1. My point is going to be x1 comma y1. I need to go ahead and find m first. So m is the difference in my y coordinates. So 0 minus 3 over 1 minus negative 2. That's going to be 3, or negative 3 over 3 gives me negative 1. Okay, so continuing, y minus, I can pick either point. It really doesn't matter. I want to pick the easier point, which is going to be 1, 0. It really doesn't matter which one you pick. So I'm going to do y minus 0. It's going to go in there, is equal to m. I just found that. That's negative 1, x minus 1. Distributing just a little bit, y is equal to, distribute that negative 1, negative x. Negative 1 times negative 1 is plus 1. So that gives me y equals negative x plus 1. D is really similar. So in D, I also want to use my point slope formula. So y minus y1 is equal to m x minus x1. I don't have a slope, so I need to find that slope. The difference in my y's, 4 minus negative 2, over the difference in my x's, 3 minus 0. Oh, sorry, 3 minus 3. I'm anticipating that 0, aren't I? 3 minus 3. I end up with 6 over 0, which is undefined. I have an undefined slope. Really good thing to do at this point is just to plot what you've got to see what's going on. I've got 3, negative 2, 1, 2, 3, negative 2. And then 3, 4, 1, 2, 3, 4. Those 2 points determine my line, and I see that I have a vertical line. This one is not a function. So I can't express it as a y equals or as an f of x equals, but I do notice that in each of these points given to me, x is equal to 3. Actually, everywhere along this line, x is equal to 3. That's my whole equation. So my equation is not a function, so I can't do a y equals, but this one is a vertical line, x equals 3. You can actually plot any of these. I'm not plotting all of them, but when you end up with something like undefined, plotting it is a really great way to figure out what to do next. E, so I'm given function notation this time. I know that I need the slope at least to begin with, which I don't have, but I do actually have 2 points. My function notation has x as an input, so I can change both of these into an xy point. So negative 1 is matched with 8, and 2 is matched with 14. I've got 2 points. That means, again, I want to use that point slope formula. mx minus x1. Let's find m. So m is the difference in my y values. So 14 minus 8 over the difference in my x values, 2 minus negative 1. 6 divided by 3, which is 2. We saw that one before. So m is equal to 2. The next thing I need to do is just choose either of these points to be the one that I plug into my formula. It doesn't matter which one. I'm just going to grab the first one. It really doesn't matter. So I'm going to call this point number 1. And I'm going to plug that into what I've got for my equation. So y minus y1, that's going to be my 8, is equal to m. That's the 2 that we just found. X minus the x from my point, negative 1. Okay, let's go ahead and clean this up a little bit. So I've got y minus 8 is equal to 2x plus 1. I'll distribute that 2. Y minus 8 is equal to 2x plus 2 times 1. And now add the 8. So y, I've got just enough room, is 2x plus 10. Okay, y or f of x, 2x plus 10.